Hey everybody, it's Mrs. Golson here. This is my fifth take recording this video, so hopefully I can get it right this time. Excuse the fuzziness of the quality. I don't have my work computer, so I had to kind of take pictures with my janky phone. I don't have the newest technology, so this is the best quality that I got. So I'm not going to read the questions because this video has to be under 15 minutes. So I'm just going to kind of give pause breaks to tell you I am doing number 2. Go ahead and read number 2 because the longer I take to read these, the longer the video will need to be. So let's get started. I will give you the correction format in class tomorrow. Let's start. So take a minute, spend time reading number 1. All right, so the question is, what is the unit rate, or what is the rate at which the water is leaking per hour? So I've got to divide these fractions. So I'm going to divide it in the way that they asked me the question. So it's asking me about water leaking per hour. So water per hour. So I'm going to take the fraction for water, which is 1/5, and divide, because anytime I want unit rate, I have to divide. I'm going to divide it by the time, which is 1/2. So how do you divide fractions? You're going to multiply by that multiplicative inverse, or in short-term speak we say, or shortcut speak we say flip. But that flip is actually called a multiplicative inverse. So I'm going to do 1/5 times, flip it, 2/1, multiply straight across, and I get 2/5. So the unit rate is 2/5 full per hour. So every hour is filling up 2/5, 2/5, then another 2/5, then another 2/5. Okay? Take a second and read 1B. Okay, so the format for our equation is y equals kx. So I always take out the k and put in constant. They don't use c for constant. Remember, they use k because c is an important number for circumference. Could mean some other things too, but let's do that. All right, so I'm going to take out my k, and I'm just going to rewrite it with the constant that I found above, because the constant of proportionality is the unit rate. They're the same thing. So this is going to be y equals 2/5 x. So since x represents hours, for whatever amount of hours I decide to put in for x, if I multiply it by 2/5, I get how much that bucket will be full. Okay? So take a moment, read letter C. Okay, so hint, a full bucket will overflow. And in fifths world, a full bucket, or 1/2, is 5/5. So I'm going to use the rates that have been given to me to see how long it's going to take me to get to 5/5 of a bucket. So remember, since x is hours and y is buckets, I can make a table for this. I can also use that equation, but we haven't been that strong in that. That's something we need to practice a little bit more. So I know they told me 1/5 when x is 1/5, or I'm sorry, when my time, this is time, and this is buckets, because that's what they told me. X is hours and y is buckets filled. All right, so when in a half an hour, my bucket is 1/5 of the way full. Count by 1/2, count by 1/5 for the buckets, or count by ones, like hours 1, 2, but you got to know and be able to visualize it. Okay, so after 1 hour, it's 2/5 of the way full. I'm going to come over here and finish my table. If I add another half hour at 1.5 hours, it's going to be 3/5 of the way full, if you can see what's happening. Every half hour gets a fifth. In 2 hours, I'm 4/5 of the way full. And in 2.5 hours, I'm adding halves, The bucket is 5/5 full. Okay, so at what point does he have to come back home? He will have 2.5 hours. So he can be gone for 2.5 hours. That's just one of the ways that he can do this, that he can be gone. Okay, take a minute and read, oh boy, number 2. Here's number 2. I forgot to take a picture of that page. Shh. Okay. All right, here's number 2. All right, so I've got this store, and there's an item that's $175. And I'm trying to find the sale price after 1/5 of it is taken off. Multiple ways to do this. Some people did a pictorial representation. Some people did the equation that I showed them. And you can also do a 2-part percent problem. I'm going to do that 2-part percent problem because, so 1/5 off the original price. So I need to know what is 1/5 of 75 or 175. So 1/5 of, when I see that in math, that means times 1/5 of 175. Okay, how I solve this, got 1/5 times 175, and I'm going to put that over 1. And now I've got 175 over 5. Some people knew to just instantly, since it's talking about 1/5, I'm going to cut 1/5 into 5 parts, and that's how you do that. After you do that, 1/5 or 175 divided by 5, that is 35. So this represents the discount, because remember it's 1/5 of it off. So I'm going to take off 1/5. So this would be 175 minus 35. This is your original price minus your discount, and you're left with the sales price. And 175 minus 35, that's going to be 140. So your sales price for your item in that store is $140. There is another shorter way that several of you did, but I'm just sharing this way with you. All right, take a minute, read number 3. Not a cedar, but a sweater. All right, so this is a double multi-step ratio problem. Okay, so he's got this sweater. It's 1/6 of the original price, and the original price is $96. So I'm going to do that first. 1/6 of 96. I like this way, and you do need to know this way, but either way works. I'm sorry. Get that off the screen. Okay, so I need to do this a little bit better. I need to write better here. Okay, so 1/6 of 96. I like it this way too. 196 minus 1/6 of 196. But that's the equation I prefer, but we can do it this way. So let's do 196 or I'm sorry, I keep saying 196. 1/6 of 96. That's going to be 1/6 times 96. Put that over 1. Keep it 96, which will be 96 divided by 6. And that will be, I got to do that. Okay, and there is going to be 3 left over, so that's going to be 6. All right, so 96 divided by 6, that's going to be 16. So remember, this is the discount. So I've got to take my original price, subtract the discount, and I get $80. Right now, this is the sales price after you take off that 1/6, but this is not it. Now, it says when Dion gets to the register, a 1/10 sales tax is added. So I got to find 1/10 of the sales price. So I'm going to do 1/10 of 80 1/10 times 80 over 1, which gives me 80 over 10. Or you could have just divided it by 10, and you get 8. So 8 is the sales tax. A lot of us say, oh, I got 8. That's the answer. No, that's the sales tax. That tax has to be added to the sweater. So I've got to do 80 plus 8, which will be $88. How much did Dion pay for the sweater? He's got to pay $88. Okay, I can't write over here if you see because my screen is cracked. You can't see that. Okay, take a minute and look at number 4. All right, number 4. Okay, number 4 is similar to number 1. You have to find the unit rate, but here they gave it to you in minutes. In minutes. So there's a couple different ways you can approach this. I need to either convert minutes to hours, or I can find the unit rate per minute and multiply that number by the minutes in an hour. So I know that 15 minutes is 1/4 of an hour. Because if I draw a clock, each of these sections is 15 minutes. And this represents 1/4. So 15 minutes is 1/4 of an hour because it really starts off as 15 out of 60, right? And when you simplify that, it's 1/4. So now I'm going to find the rate. It says, what's the rate you're laying in bags per hour? So I got to do bags divided by the hours. So I use 1/5 of the bag. And in the hours they gave me, that's 1/4. So I'm going to keep change, flip, or multiply that by that reciprocal, that inverse. So this is 1/5 times 4 over 1. And that gives me 4/5. So it says, what's the unit rate for bags per hour? 4/5 of a bag in 1 hour. That's how much I use. Okay, don't use the whole bag. I use 4/5. All right, look at B. Write an equation. That's just y equals 4/5 x. Because your x is hours and your y is bags used. So any number of hours you put in for x, you're going to multiply it by 4/5 to get the y. That is the equation for the proportional table. All right, let's look at C. C is about the same situation, but totally unrelated to A and B. Uncle's working faster than us. 3 bags he uses, and then I use 2. So I'm just going to make a table for Unc and me, since they told me about Uncle first. He uses 3 bags for every 2. So 3, I use 2. Another 3 for Uncle will make 6. Another 2 for me will make 4. Another 3 for Uncle will make 9. Another 2 for me will make 6. Another 3 for Uncle will make 12. Another 2 for me would make 8. So this is increasing by 2. And this is increasing by 3s. Because Uncle, that's what Uncle's doing. So it says, is this relationship proportional? Explain your reasoning using a graph on a coordinate plane. Well, Uncle is X. Here's Unc. Me is Y. Here's me. Just going to put some notches. Okay, when Uncle is 3, so here's 1, 2, 3. You can put your numbers on there. When Uncle is 3, I'm 2. Check. When Uncle is at 6, I'm 4. 1, 2, 3, 4. Check. When Uncle is at 12, I cannot draw over there because my screen is cracked. But if you see where this is going, it will be a straight line. So explain your reasoning. Yeah. Because we got a straight line through the origin.